Welcome everyone. So in this talk, we'll talk about Prestissimo at Meta and batch performance and production. I am Amit. I am working as an engineer in Facebook, Meta, and we will also have one of our biggest customer of Prestissimo. His name is Nathan. He will join with us in the presentation also. Okay, the content of the presentation, first we'll start with some introduction and then we'll give an overview of the entire batch workload, what Presto does inside Meta. We'll go over some recap that we did for PrestoCon, and then we'll discuss about where Prestissimo is in the warehouse batch. And then we'll also talk about Prestissimo experimentation platform batch, which Nathan will present. And then we'll discuss verification and how we put it in forward for production, community contributions, some of the Velox inspired improvements in Presto Java land, and what's next. So the Presto batch workload at Meta. So Meta has one of the biggest deployment of Presto with many hardwares, lots of user using, with variety of workload using all sorts of Presto features. And not only just the open source features, it has a plethora of internal functions, internal connectors, to connect with many storage systems inside the company. And the workload, usually wall time for batch is 5 minutes to 1 hour, and there are a wide variety of workload. There are periodic workload that runs to certain interval, like every hour or every 15 minutes or every day. And there is a ad hoc workload that comes that does not have any period, but it comes whenever customer wants them to use. And also this workload have a specific tiering. That means we need to give some guarantee to the customer that how this workload will perform. It has one of the major things that batch has is the writers. So most of the batch workload actually tries to write something in our storage system, but it's also not just the inserts. It's also some transformation, ETL, and all kind of workload. Then we have Exchange that works in very big size clusters, not in 10-20 node cluster, but it order of magnitude bigger. The workload is always CPU and memory hungry. They are always competing for CPU, competing for memory, and the variety also creates a lot of interesting situation in the cluster setup. Meta also has large batch mode, which is kind of exchange materialization to make exchange durable. The execution time is also quite fast. That's why people, the engineers and the customers use Presto, because even if there is not a lot of fault tolerance, but the execution speed is faster than other batch frameworks like Spark. So everyone likes this part. But at the same time, in a company like Meta, the requirement and the expectation from customer keeps growing and growing and growing. And we even in Meta scale, we are hitting the limitation of the hardware, and the expectation of customer is also getting more and more tighter to make performance better, to run things faster in a smaller footprint of machines. So this is how roughly it looks like inside the company. At the same time, as things go forward, there are evolving requirements. I think Pedro touched some of these file formats, but There are machine learning file formats like Alpha and Nimble, and one of the important thing that customer wants is they want to run SQL on top of those. They want to see if these machine learning files are written properly. They want to debug, make dashboards, run ETLs, all sorts of things that they can do in traditional storage like DORF or ORC or Parquet. So the requirements getting evolved. So there is a major requirement of SQL on machine learning file formats, similar like periodic and ad hoc workload. And the performance and speed of execution is extremely important in those cases because these are orders of magnitude bigger in terms of files. And again, the capacity and hardware is limited. And the natural inclination in the company is everyone want to use Presto because it allows you to run SQL. And so with all these requirements, we also want to run a homogeneous fleet that can work with traditional and new formats, not just we build something for the new format and a new query engine, but can we run them all together? So these are all the new evolving requirements coming in. Same time, the correctness. So Presto is a decade old. It has a decade worth of fixes, right? It has many fixes over the years since the inception in Meta in 2012. So it has become the source of truth for almost all computing platforms. Anyone want to verify something, want to see if an expression or any arithmetic is good, they will use Presto for it. And Presto also has the backward compatibility of results. Say, for example, if we change behavior of something, say cast or regular expression, it's probably easy to change, but then all the files written with this needs to stay backward compatible. So there are also dual behavior of many functions that are there for over the years. And above all these are uses, but the maintenance and release is one of the major things to make Presto work in the company. So the way it happens today, the verification is done with the previous version. So we sample some production workload and we see that if the results somewhat match with the previous deployed version, the current version, and it is a major deployment in a very large fleet, and in the very fast, like every 2 to 4 weeks, we try to update or we try to do it even faster. There is a need of updating it from the company, but at the same time, from our experience running this Java fleet with bigger systems require restarts also to keep it healthy. Hardware for verification. So at the same time, the fleet is mostly supporting the customer, but to verify this, you also need many hardware. Say you have to run old version, new version, many regions. So the verification itself is a complicated problem than writing Presto. So naturally, how much we can verify? We cannot verify all the queries. And also when we verify, we are also hitting the limit for the storage and metadata service, which may not be dedicated for verification. And the reliability is very important. Release to release, the customer SLO and agreement needs to be maintained by the team. So this is what Presto batch looks like in the company in a nutshell. But now we'll take a look back on the PrestoCon, what we presented about Prestissimo that time. In PrestoCon, we discussed about Prestissimo, and we demonstrated that it is a very promising platform. It has supported one of the major customers of Meta Warehouse. With it supported almost 3 times growth without any additional hardware. So this is something exceptionally well done, because this customer, the experimentation platform, they were running out of capacity, as I was showing before, and they could not support their use case in the scale of and the growth that the company has. But there are except a few special cases here, because the query shapes were mainly selects, and it's also fixed queries. And we were able to do that with Prestissimo and Velox. And we keep the verification, release, deployment weekly, even faster than what traditional Presto Java does today. So and at the same time, we also give some highlight how the Prestissimo batch would look like. So Prestissimo batch is the first use case for probably Velox and Presto together to try this new eval in a completely heterogeneous workload, where SQLs can be anything, the full suite of Presto is used. And we presented some early results, but we'll go to a comparison now. So before going to the comparison, so I want to give a highlight where it is today. The Prestissimo warehouse batch, to make it work in batch, you can see that it requires many functions, connectors, features, scalability requirements to match what Presto Java has. Not just efficiency, the feature, the breadth of the requirement is very wide. And in a wide in that width, we really need to understand what to implement, what to prioritize, and more importantly, how to put Velox in production in a reliable and sustainable way. But also, don't wait for writing everything, right? That there is, how can we balance this? This is a very tricky, becomes very tricky project. At the same time, Presto deployments, so it's almost changing an airplane engine while in flight, because the warehouse is already running, right? The warehouse is running with many workloads, pipelines, queries, dashboards, analytics, monitoring, you name it, Meta has it. How do you change some of it while it is running? And what kind of mechanism, what kind of traffic routing, what kind of verification you put to do that? And at the same time, maintenance of two flavors is gonna be double hard, right? Because you already have a Java fleet that require release, maintenance, fixes, introducing one more. And if you do that, then you fork the release and everything in two places. But then as a company, we need to do the migration very quickly. The velocity of migration is probably extremely important, because keeping it two places will not sustain for a long time, right? Because we'll not have that amount of headroom, headcount. Also, as a software, it's hard. So we need to converge quickly to Velox. And how do we strategize in this environment, and how we shape Velox's feature with this is what we're going to describe. We'll talk today. Okay. So for this, we need to figure out a different development strategy, not just a canned query, but we need to find something else. So what we started doing is we started shadowing production traffic from day zero, and we started defining some of the key metrics. The key metrics will drive us that, okay, if the software is almost 90%, 95% there, and then we go in deployment. So the metrics that we usually use are the success rate by count. So that means in a time bucket, how many queries are successful, not correctness, just successful in terms of query in terms of query completion between Presto Java and Prestissimo. So this is, you can see it is more geared towards coverage. If more query completes in both systems, meaning in Prestissimo, meaning Prestissimo has a wide coverage. But at the same time, we also need to see, we do not run only the easy queries, right? We want to run the heavy lifted, like 10 minutes, 20 minutes, 30 minutes queries, heavy CPU intensive queries, where Velox really gives the win. So we want to see success rate by CPU. So then we plot in a time bucket, we take all the CPU time ran by Presto Java, and then we also do this for Prestissimo and see the ratio. And this gives us success rate coverage by CPU, but at the same time, coverage does not give a motivation to put it in production. To have it in production, we need to really demonstrate it can either squeeze the footprint half or run increase the throughput by 3-4 times, which is what we saw for our experimentation platform use case. So we also define CPU execution and wall time ratio, where we sum the CPU time, execution time, and wall time from Java and divide it by the C++ shadow workload, one-to-one mapping of queries, and we see how many times C++ is good, or when it is bad, and if bad, why it is bad. So these are the major things. This suite of metrics will allow us to take the software forward and fix the important part of Velox, instead of making it white covered, but making it solid and make sure that it can fit our workload. At the same time, reliability is paramount. That reliability is the job for the company, for Meta. So we want to see how many crashes are observed. This is a brand new infra, so it will go. It has gone through many crashes and everything. And at the same time, if you are a developer here in Velox and Presto, you really want to see how quickly you can test a fix. For example, okay, I fixed something today. Do I need to wait for 2 weeks to see if it will work out? Or is it a fix that does not crash always? It is maybe sometime it crashes, sometime it fails. Or it is a memory buildup. So the things can get very complex. So we need to make sure developer velocity is also there. So we need to make the continuous loop for continuous feedback loop for the developers, so that they can quickly iterate and fix things, so that we can migrate faster. And then the other goal of it is build a generalized platform. So get by products as plus. This means that we want to cut the workload in a way that we can deploy some part of it in Prestissimo and go forward as it gets more mature. But we do not take any decision that is very particular for certain workload. So this is very important, because our end goal is inside the company is to converge to Velox. Okay, so with this, what is the verification strategy? So this again, the wide variety of workload, and just to Java, you have the decade worth of fixes that I keep saying, right? And then you have verified it over and over and over and over for 10 years. So you know, generally it's okay. But for a new infra, it is extremely hard. It is probably the harder than developing Velox, because how do you know this is matching with the Java? You cannot run hundreds and thousands of queries. Just not have that capacity, right? So then we need to really understand the workload. So then we start cutting it. How do we cut it? You cut the workload if it's a deterministic workload. Okay, if it is a function that will give same result in Java and C++. Okay, so we find a plan for them. But what about non-deterministic? There is functions that are not same in both, and that is majority, like 40-50% cases they are different. The workload is different, they are non-deterministic. In that case, we need to find a way in Velox that the non-determinism is covered in certain way, right? And we also see in our workload there are a lot of queries. They are same query, different parameters. We call it templated patterns, and these are our like a gold spot to migrate, because they are easy to migrate. We know the patterns, we can learn the patterns, we can test this easily. And there are all sorts of ad hoc queries. And there is retrievable and non-retrievable queries. Some query you can run and fail in C++, if something is not available, and you can run in Java. But not always you can do that, right? So then how we migrate all these things? At the same time, the complexity goes in another dimension, and behavior changes fundamentally in between C++ and Java. For example, JSON parsing in C++, we'll talk about SIMD JSON. This is very efficient, but there is also its behavior is not exactly same how the Java one works, and there is a whole lot of dependency on the Java side. So we not only now need to do a migration, we need to deprecate some of the Java part also. So the problems get complex. There is regex Ioni versus RE2 has quite a bit of difference. So to go to Prestissimo Velox, we need to migrate the Ioni to RE2 even in Java and then go to Velox. So consolidation becomes another problem. So it keeps coming. And we need to verify at the same time, Velox in this platform, we need to verify very fast to fix the bugs daily, maybe even hourly. And how quickly we can orchestrate this kind of infra is also something non-trivial, and it does not come in open source that much. So these are all non-trivial, complex, and hard problems, not straightforward to deal with. But to migrate the warehouse, these are the problems we need to tackle. Okay, so today, now with all those, say once we tackle those problems in workload cutting and verification, this is the comparison where we are in November 2023 and versus April 2024. So the success rate by CPU and by count has been increased significantly, and the coverage part has come a lot from community contribution. So thanks for that. We'll talk about it later also, but that's how it went high from 90% to 95%. At the same time, by CPU, we are almost at the 80% of the Java worker, which means we are running almost all the big queries. And the reliability wise, we used to have smaller than 5 crashes per day. From here, we went to very rare, like almost 2 crashes per week. For a new infra, this is exceptional, and the Velox and Presto folks did a fantastic job hunting down the crashes aggressively and fixing those, and all of them are non-trivial fixes. Correctness rate. So we had a correctness rate of 90% on 2,000 queries in November, but we had to change our infrastructure to support way more queries. So we went to 20,000 queries. We have some verification tricks and algorithmic changes that allows us to do that. And we also improved the correctness to 98%. And we are applying more and more stuff like deterministic, non-deterministic, fuzzing with Presto to make sure the verification becomes faster and does not require an end-to-end verification with Java and C++, which is expensive, hard to do, and faulty because of it depends on many systems, right? So at that point, we did not have a production timeline, production readiness, because we are still on early stage. But today, we are quite confident that the verification, workload routing, workload understanding, Presto fuzzer, non-deterministic queries, behavior discrepancies are kind of understood, sorted out, have a plan. So we have a timeline to go to production in April 2024. So that's where it is today. So now to go to production, the important part is the metrics that I keep talking about. They need to give us something meaningful. It's not just rewriting something in C++. That does not give anything for the company. It needs to give benefit to our customer, make it reliable and performant. All these things need to happen. So one of the key among those metrics, one of the key one is this ratio that we keep looking at, sum of the Presto CPU and execution time divided by sum of the Prestissimo CPU and execution time for a specific set of queries that run in both cases from our shadow system. And we take the timings for queries that are successful in both systems, and then we use this along with success rate and count, and we also see the percentage and absolute values to see if it's a good fit. So with that, we come to this kind of chart, this kind of ratio. So if you see, C++ in batch is almost 3 to 4 times better in terms of CPU time. This is exceptionally well, given it is running almost 80 to 90% of CPU heavy workload, which means that the platform is actually future proof, what we wanted it to be. And at the same time, the execution time, because execution time is not only just CPU time, but it also involves going to storage, metadata, exchange, everything is involved. So that is also almost 1 to 1.5 to 2 times. And the up and down, that gives a picture that how variable the workload is. It's not the same queries, same shapes running every day. So someday, some functions, say for example, you hit a lot of JSON functions, you score out of the park with SIMD JSON, but next day something else comes, so we need to look at. So it is fluctuating, but general trend is extremely promising. So it is a future-proof platform for us to invest and migrate heavily and complete it very quickly. Okay. So the highlights of Prestissimo batch is it is a reliable platform. It is much more maintainable and fast execution platform. And all these three gives fantastic customer experience. At the end of the day, that's the only thing matters for the warehouse analytics, because we need to make sure our workload runs faster. People can run the dashboards, engineer can run the dashboards faster. So this is this gives us that capability. 3 to 4 times better in CPU time, almost 2 times better in execution time. And the bigger part is it's also 60% less in hardware. Or you can see that, okay, you can utilize the reduced hardware to get 3 times more throughput. Okay, so from there, we define the verification and path to production. So now we already demonstrated that this is 80% of our 80–90% of the CPU heavy workload. But then how do you put in production? Because the Java cluster will run all the queries. How do you differentiate on the fly that this will go to C++, this will go to Java? What about sometimes query go from Java to C++, C++ to Java? All sorts of things can happen because it is a heterogeneous state. We cannot convert, migrate everything yet. So we have built mechanism to pin traffic. We have built mechanism how to avoid or how to tolerate bouncing between back and forth in C++. We have invested on also investing on HBO to make it work in C++ and history-based optimization to work it really well between both eval. We are going with first the deterministic workload where the results are same. And we also want to go with the retriable workload where if something fails, then we'll retry in the Java cluster. But that will take us to the fast deployment. So we'll initially deploy with verified and tagged workload, and then we'll quickly ramp up to different regions. And at the same time, we are enhancing the fuzzer to support the non-deterministic cases so that we can enable those things. And we need to get a escape velocity for migration. So we need to reach to a position where 90% or even more clusters inside Meta in Prestissimo, which means the critical path is covered. At that point, we have a few clusters for Java where the long tail is there, so we can go there a little bit slower. But the critical path needs to be completed very quickly so that the team does not need to maintain 2 infra for a very long period of time, which is very complex in a scale that we operate. With that, do you have Nathan on the line?
Yep, I'm here. Can you hear me?
Nathan, go ahead. Yeah.
Cool. Yes. So first, let me just quickly introduce myself. I know I was late to this. So I'm Nathan. I'm an engineering manager here. I support a team within the experimentation platform, specifically Deltoid, which is our experiment analytics platform. My team builds the infrastructure powering those analytics. So I wanted to talk briefly about kind of the business impact of some of this work that we're doing on Presto and Prestissimo, and give some context for why this is important. So our current setup today within the experimentation platform is that we have this split brain problem. Our interactive queries run on Presto, and our batch queries run on Spark. For Presto, we're generating those queries through a set of Python services, while in Spark, everything is built in Scala, a custom Scala application that includes a whole bunch of business logic and interfaces with Spark. So completely separate implementations, essentially no shared code between them. And the setup, of course, leads to a lot of problems over time where they get diverging feature support and ultimately different methodologies, right? So if you run effectively the same query from the business standpoint through each of these systems, you may get different results just because they're applying different methodologies. We also have relatively long runtimes on Spark. Our P99 is somewhere around 6 hours for this workload. So that also presents some operational challenges. Why we have this problem? Well, there's a whole lot of legacy reasons. This is a platform that's evolved over about 10 years. And at least the common wisdom over that period has been that Presto was not really suitable for large workloads like ours. So if you can, next slide. So what do we get from unification on Presto, which is our goal for this year and next? First of all, of course, we get a single query gen code path, which gives us lower development costs, lower maintenance costs. It's going to lead to more consistent results as we make those methodologies consistent. And of course, then we can develop features faster when we no longer have to implement them twice in 2 different places. We're able to up-level our performance. So actually, even just Presto Java gives us a P99 runtime of less than 2 hours, which gives our customers improved landing times for their data in the experimentation platform and reduces things like our operational risk, time to recovery if there's a SEV, and that sort of thing. And finally, it gives us execution flexibility, right? So as we unify on Presto SQL as our expression of what our queries should be doing, there are multiple different ways that we can run that. We can run it on dedicated Presto Clovers clusters. We can run it on the Presto batch clusters in the warehouse. Eventually, we could run it on things like Sapphire on Spark. So it just gives us a lot more flexibility than a dedicated Scala application does. Next slide. And so finally, here we were talking about Velox and Prestissimo. So what does Prestissimo add to this equation? So first, it's been a great platform for us to really optimize the workload for the experimentation. We went through many rounds of experiments on just the cluster configuration and setup, different cluster sizes, different hardware types, different configurations of things like caching and spilling and concurrency, all of these tweaks that allowed us to really find the right configuration for our workload that maximizes our throughput. We're also able to implement some really targeted optimizations in Velox itself. The example here is using hash map instead of sorting for Velox map subscript operations. This was a really key optimization that brought our execution times down significantly, which you'll see on the next slide. So impact of Prestissimo on top of the baseline Presto migration is, first of all, that it gives us a single cluster configuration for all of our experimentation platform workloads. So the interactive or ad hoc queries that we're running now has this same cluster configuration as our batch workload will. So that gives us flexibility and able to use those same clusters for multiple different purposes. When there's off-peak hours for interactive queries, we can then use those same clusters for batch queries. It gives us significantly lower total hardware costs. So we were able to find a configuration on Prestissimo that required no local SSD storage, which of course lets us use much cheaper hardware configurations. As Amit mentioned, 60% fewer nodes per cluster necessary for this workload, which allows us to greatly increase the number of clusters that we're running, gives us more total throughput. It also has some nice benefits when our customers come to us and want to add capacity for their own uses. If they have to bring us 60% fewer nodes, right? That just enables them to add capacity in a much lower friction way. And finally, the performance wins. So going onto Prestissimo, we were able to bring our P99 down by an additional 50% to less than 1 hour. Our total workload on Presto Java was taking about 23 hours for a day's worth of work. So that's very close to the limit of it becoming impractical. Prestissimo enabled us to bring that down to 9 hours. So that gives us a ton of extra headroom. Any sort of, if there's a SEV for 8 hours, great. We've still got plenty of time in the day to recover from that and complete the workload. All that is going to lead to better adherence to our SLOs, faster incident recovery, and ultimately for our customers, more analytics power for them so they can run more experiments. They can compute the impact of those experiments on more metrics every day. They can apply more sophisticated analytics on those metrics. So just enabling our customers to do more. Cool. I'll stop there and hand it back to Amit.
Okay, thanks, Nathan. So you see how Velox and Prestissimo powered the customers, right? This is the main goal for the company, to make the analytics faster and better, and then the software side we converge a lot. So now I want to touch a little bit on the community contributions. So community contribution from Velox and Presto has been the major driver for success rate coverage improvement. There are many items. I just added a few, but to highlight, there is the SIMD JSON that being added to Velox, and that just made many queries 10 times faster, because JSON parsing is a very popular workload feature, and SIMD JSON just knocks it out of the park. So thanks for including this. Window functions. Window functions are one of the most popular functionality that, at least in our company, in Meta, the data engineers uses. People like window functions like nothing. So really thankful for Aditya and others for adding this adding this feature in Presto, Velox, and making sure that we can run those workloads. It significantly improved our coverage, because almost a good number of queries will use window function. Date time functions, types, decimal, cast enhancements like decimal casts. There are many fixes on spilling, exchange improvement that Mang and others did from open source side. Simply put, the metrics that we have demonstrated would not have been possible without the contribution we got from community. So really thankful for everyone to jump in this platform and make Presto faster with Velox, and we really want this to continue to go forward in here. Yeah, so we're thankful for the contributions. We really expect more continuous contributions. Functional performance, reliability gaps between Presto and Prestissimo, anything that you see in your deployment, let us know, and we can work together. Now I'll touch the reverse part of the Veloxification, right? When you do the Veloxification is a term what we use in the company to convert back infrastructure to Velox. But when you do that, you get a chance to fundamentally look some of the things that have been done in Java for maybe 5 years ago, 6 years ago, 10 years ago, that we generally do not look. But now we see, okay, there is 10 times performance difference. Can we do something in Java side as well? And yes, that we can. So there is a hyperlog log improvement that Pranjal and others figured out that the C++ part is really efficient. So they started looking back in why Java this is slower, and they improved it. There is NaN comparisons that have been buggy in the Presto Java that have been consolidated and improved. There is a precision loss from Unix time that has been fixed. All of these are in Presto Java side, based on what we find from our experiment and in fuzzing, and then allow leading and trailing spaces in cast to be compatible with SQL standard. These are also fixed in Java side, and there are many more. So it does not just go in one direction; it enhances both, because now you can get the chance to see both infra in a lens that we haven't seen before. So to end, the Prestissimo is reliable, maintainable, and fast execution. That's what we want to go. Gives us fantastic customer experience, which is our key metric, and it is powered by Velox. And thanks everyone, Presto and Velox team in Meta, because it's been a very complicated project to fix all the crashes, functionality gaps, performance gaps, being very nitpicky about performance all time. It's a hard project. Thanks to everyone outside who worked with us, who are working in Velox, helping the project to go forward, making Presto to move forward with adding more and more coverage in Velox and Presto also, and definitely meta experimentation platform, which I often say is a mini warehouse. They have a very big business to run, and they have been very helpful. We had to have a good customer story to make this project a very promising project. So thanks everyone.
A few minutes and then we'll go to break.
Hi. Yes, my name is Ron Barber. I had a question on, you talked about 60% less hardware, but I was just wondering, don't want to draw out the actual, I mean, that could be assumed to be CPU or memory, but I mean, Velox shows to be a great savings in memory, and I was just wondering why you don't sort of talk about that specific aspect of it, that it is much less bloaty than a Java environment.
Yeah.
So
Yeah.
I mean, it seems like it's worthy of mentioning as a bullet, separate from just 60%.
In this presentation, though, I tried to cover the customer and Presto aspect more, kind of how do you change this warehouse in C++. That is, I try to go in that angle a little bit more than, because the Velox part is already known. It is more CPU efficient. Its caching is better than the Java Alexio caching. So we already know in theory they are good. But in practice, does it solve the problem for the company? So that's where the funding will come from to make it work. So those are the key metrics I wanted to touch, but exactly, you are right. And there are more things will come in Velox. I think 60% is what the number we see today, but our experiment, I don't want to publish it right now, but it's even less.
Yeah.
It's almost like, if you ask Ori, it's 1/3. He's looking for 1/3. So.
I'm sorry. How do you, so you're saying that like over 50% of workload is actually non-deterministic for you. And how did you actually come up to conclusion that like, hey, like basically verification is actually working for us? Like,
so those are very interesting problems that does not come to open source that frequently, right? The thing. So what we did is, it's very simple. So we have a list of functions over the years when we release Presto. As I said at the beginning, I touched, when we release Presto, even for Presto Java, we compare with previous version and new version. But we cannot compare non-deterministic functions. So we had an understanding in the company, these set of functions are non-deterministic. So we always filter out a big set of functions from our verification suite, and we just rely on unit tests. We took those and ran into our entire workload and figure out what percentage of that represent. So basically all the workload, and you filter out the SQL text based on those functions, and whatever remaining, we can say those are deterministic, and these are probably non-deterministic.
Because like verifier is doing checksums at per column level, basically, right? And let's say if you have a prox distinct or a prox percentile, something like that, you just treat it as like same.
So we have another, I don't know if we learn that is in open, but what we do is, so when you learn Velox, right, for non-deterministic code, it's very interesting. How do you know that the new one is good? So what we do is we added something in verifier that replaced the non-deterministic function with the deterministic one. So we can check the shape. So the shape of the query, if you run it through eval, you'll see that if it crashes or not, or if it runs performant or not. Say for example, if I approach this thing, remove it with average for the time being. But the queries are so big, so we need to do some in the syntax tree to change it. But once we change it, the query becomes deterministic, so we test it as deterministic. But then comes to this Velox father story. Okay, for those functions, father gives us signal. Okay, these functions are certified by father. Okay, that approach this thing is ready for unit test level, and the shape we cover with the verifier by replacement. Together, this gives us the confidence this will go work. But again, we cannot do this in warehouse worth of workload. That is the major problem. How can we cut it even the workload, what are the templated, like some queries does not change. So we target those things faster. And the repeated queries are usually same.
Yeah.
There is some domain knowledge we also apply. But all this is to, because in one side you do not have all the features. Another side, you cannot develop it for 10 years. That is not going to work. The project will not survive. So we need to go to market and find a path that it goes to the critical path and make the Java side kind of sit idle, and then we do the long tail migration.
May I ask one more question about the crashes? You were mentioning that, like, say in December you had less than 5 crashes.
Yeah.
Or something like that. Like right now, it's like very rarely like 1 or 2 per week.
Yeah.
What is the per capita numbers? I mean, is it like in the scale of like all the crashes, like at all meta fleets, or like is like, let's say on an average cluster of like 100 nodes, something like that?
So this is, the crashes are two kinds. There are unique crashes, there are total crashes. So unique means, say you saw one crash, but it can happen, say if you have 20 node cluster, say I give a small example, then there'll be 20 crash, but we just count one. If it's a unique, we try to see if it's the same crash everywhere. Then we don't count it.
Oh, it crashes multiple nodes basically.
Yeah,
yes.
But the fix is same. But the workload wise, we in our regional workload, one region kind of 90 to 95% represent the entire footprint of many regions, because there is not much variety. There is variety, but not much. So we tried in 2 regions so far, but we have some more regions, so we'll need to try there. But whatever we tried, based on that, it is significantly reduced. It's not zero yet, still there, because there are a lot of new chains coming, but it is in a position where we can go to production. I mean, to make it perfect, it will take time.